Hi, do you know what I'm doing? I'm doing a simple experiment. Do you want to know how it works? Let's find out.
Electromagnets play a crucial role in various applications, including electric motors, transformers, and MRI machines. Understanding the principles behind electromagnetism and how to create a magnet using solenoid is fundamental in exploring the relationship between electricity and magnetism. This project aims to demonstrate the concept of transforming a solenoid into a magnet by passing an electric current through it. Purpose of the experiment. The purpose of this experiment is to investigate the process of converting a solenoid into a magnet. Through what? Through the application of an electric current. By constructing a solenoid and we observe the effects of current flow, we can aim to understand how the electromagnetic field generated within the solenoid can magnetize a ferromagnetic material. In this experiment, we used an iron nail. And furthermore, we will explore a factor that influences the strength of the magnet produced, that is, the number of turns in the solenoid. For the materials, the first one is iron or steel core. In this experiment, we use nail. Next, we use copper wires, power supply, which is battery. Any kind of battery is acceptable. And the last one, we will use steel object. In this case, we use paper clip. For the solenoid preparation, take the nail and the copper wire. Wind the copper wire tightly around the nail to form a solenoid. We need to ensure that the turns are closely spaced and parallel to each other. Leave excess wire on both ends for connecting to the battery. Next, attach one end of the wire to the positive terminal of the battery and the other one to the negative terminal. Now we test the electromagnet. We test the strength of the electromagnet by bringing the paper clips near to the core. The object should be attracted to the core. As we change the number of turns in the solenoid, we can observe that there is a change in strength of the electromagnet.
As for the result, when we increase the number of turns in the solenoid while keeping the current constant, it is expected that the strength of the magnet will increase. This is because the magnetic field generated by the solenoid is directly proportional to the number of turns. Therefore, with more turns, there are more individual magnetic fields aligned and reinforcing each other, resulting in a stronger overall magnetic field. As for the conclusion, based on the experimental results, it can be concluded that a solenoid can be transformed into a magnet by passing an electric current through it. The magnetic field generated within the solenoid induces the magnetism in a steel core.